Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of NEET preparation, we'll be looking at previous year questions of chemistry in medical entrance examinations in India. Today we're dealing with the chapter, the P block elements. This is the 7th chapter in the grade 12 syllabus for chemistry in CBSE. Let's jump right in to our first question. The reason for not storing XeF6, which is xenon hexafluoride, in a glass or a quartz vessel is A. It forms an explosive having the formula XCO2F2. B. It forms an explosive having the formula XeOF4. C. It forms XeO2, which is explosive substance. D. It forms XeO64-, which is explosive in nature. Well, when it comes to a reaction of XeF6 with quartz, we see that 2XeF6 reacts with silicon dioxide, which is glass, to form 2XeOF4 plus SiF4, and that on further reaction with silicon dioxide in the end forms XeO3, which is explosive. So we know that XeOF4 as well as XeO3 is very explosive. However, XeO2F2 is not explosive, so therefore option A is incorrect. Similarly, there is no formation of XeO2, which makes option C incorrect. And the ion XeO64- is not explosive. The only things explosive are XeOF4 and XeO3. So therefore, option D is incorrect. It is also incorrect because there is no formation of XeO6. Therefore, the right answer is option B. It forms an explosive having the formula XeOF4. As you can see, XeF6, 2 molecules, reacts with 1 molecule of glass, which is silicon dioxide, to form 2 molecules of XeOF4 plus silicon tetrafluoride. So, option B is the right option. Let's look at our next question. What are the products formed in the reaction of xenon hexafluoride with silicon dioxide? Basically, XeF6 plus SiO2. So when it comes to XeF6 and SiO2, we have the oxygen removed and the ions are exchanged. So the anion of oxygen is replaced by the anion of fluorine. So O2 has a total valency of -4. So therefore, in order to satisfy -4, we should have 4 fluorine atoms. So therefore, SiF4 is formed. And then the remaining, we have 2Xe. And then we have O2 as well, F2 as well. And we have 2 oxygen. So it becomes 2XeOF4. So the right answer is option C, XeOF4 plus SiF4. So over here, the xenon gets oxidized because oxygen is removed from silicon and it is added to xenon. So silicon dioxide gets reduced and xenon hexafluoride gets oxidized. So option C is the right option. Let's move on to this question. P4O10 is not used to dry NH3 gas because P4O10 reacts with moisture in NH3. P4O10 is not a drying agent. P4O10 is acidic and NH3 is basic. P4O10 is basic and NH3 is acidic. So, why is P4O10 not used to dry NH3 gas? Well, because P4O10 reacts with water to form 4-HPO3. This is known as metaphosphoric acid. So, and when we look at NH3, when it reacts with water, it forms NH4 plus and OH minus ions. So as you can see, H3O3 is metaphosphoric acid, so it's acidic, and OH minus is formed, which makes NH3 basic. So therefore, option C is the right option. Option D is incorrect because it's given that P4O10 is basic and NH3 is acidic. And option B, P4O10 is not a drying agent, is incorrect. It's used for other drying agents, but not, it's used as a drying agent in other compounds, but not with NH3. And P4O10 over here does not react with NH3, it reacts with water in order to form an acid and a base. So option C is the right option. And the reason why being acidic and basic means that it cannot be used to dry NH3 is because you're getting essentially a different product, HPO3. So therefore, the true purpose, which is to get pure NH3 gas, which is dried, does not occur. And that's why this reason, P4O10 is acidic and NH3 is basic, is the right option. Next question. Oxygen is more electronegative than sulfur, yet H2S is acidic while H2O is neutral. This is because A, water is highly associated, B, HS bond is weaker than HO bond, C, H2S is a gas while H2O is a liquid, D, the molecular weight of H2S is more than that of H2O. Let's look at each of our options. Molecular weight of H2S is more than that of H2O, which is true because in group 16 elements, oxygen weighs less than sulfur in terms of atomic weight. However, atomic weight has no role in basicity. So therefore, option D is incorrect. Now, option C, H2S is a gas while H2O is a liquid. Just because H2S is a gas doesn't mean that it becomes acidic. For example, NH3, which is a gas, is basic. So therefore, since H2S is a gas while H2O is a liquid, this is not a reason for the acidity, the basicity of H2S. So option C is incorrect. What about option A? Water is highly associated. Well, water is highly associated because the oxygen tries to take more of the electrons from the hydrogen. So that means this happens due to electronegativity. While the question is asking us, in spite of electronegativity, H2S is more acidic. So option A is incorrect. The right answer is option B. HS bond is weaker than HO bond. And this is due to the fact that sulfur is greater than oxygen when it comes to atomic size or atomic radius. So when we have a weaker bond, it becomes easier to break. So water has stronger bonds and it also has hydrogen bonds, so it kind of makes it difficult to break water. However, H2S can be easily broken because the bond is weaker, so it forms H plus and S2 minus. And the formation of H plus, the liberation of H plus, means that H2S is acidic, while the non-release of H plus ions in water makes water by itself neutral. And when it comes to acidity and basicity, most of these are measured by the presence of H plus or OH minus in water. So water is actually the standard for this phenomenon. So it says that water has to be neutral. Let's look at our next question. When chlorine reacts with cold and dilute solution of sodium hydroxide, the products obtained are. Okay, so we have Cl2, which reacts with 2NaOH. So what is formed? So OH is minus and chlorine actually has charge of -1. So one of the chlorine goes here. So it becomes NaCl. And we have one of the other H pluses, since there are two. So one of the H's get out and it reacts with water. So it becomes water. But we also have one more sodium with an oxygen. So that forms NaOCl. So these are the products. So in NaCl, chlorine is Cl minus. Over here, the anion is OCl minus. So therefore, option A, Cl minus plus OCl minus, gives us the right answer. Next question. When Br2 is treated with aqueous solutions of NaF, NaCl, and NaI separately, what happens? Option A, F2, Cl2, and I2 are liberated. B, only F2 and Cl2 are liberated. C, only I2 is liberated. And D, only Cl2 is liberated. Here, in terms of halogens, you need to know that F is less than Cl, is less than Br, is less than I when it comes to atomic size. And in a group, the smaller elements they displace the larger ones in a redox reaction. So since the smaller element replaced the larger one, when Br2 gets treated with NaF, there is no displacement that occurs because F is already smaller than Br. Similarly, in case of NaCl, Cl is smaller than Br, so there is no displacement. But when it comes to iodine, we know that bromine is smaller than iodine, so therefore I2 gets liberated. So if you look at it, so 2NaI plus Br2 would give you 2NaBr plus I2. So I2 gets liberated. So option C, only I2 is liberated, is the right answer. Option A is incorrect because F2 and Cl2 are already smaller than Br2. Option B is also incorrect due to the same reason. Option D is also incorrect due to the same reason. Chlorine is smaller than bromine, so it does not get liberated. Now, let's look at the following statements regarding helium and find out which of these is incorrect. Look at the question. It's asking us to find out the incorrect option. Statement A, it is used to produce and sustain powerful superconducting magnets. Statement B, it's used as a cryogenic agent for carrying out experiments at low temperatures. Statement C, it is used to fill gas balloons instead of hydrogen because it's lighter and non-inflammable. Statement D, it's used in gas-cooled nuclear reactors. When it comes to helium and temperature, helium has the lowest melting point and boiling point of any element. So that means helium acts as the ideal coolant when it comes to talking about experiments carrying at low temperatures. So therefore, option B, statement B, is true. And because of the ideal coolant property, it is also used in gas-cooled nuclear reactions. So statement D is true. Now what about statement A? It is used to produce and sustain powerful superconducting magnets. Well, in order to have powerful superconducting magnets, the magnets need to be in a very cold temperature. And who provides the very cold temperature? Helium. So option A, statement A, is also true. That leaves statement C being the false option, which makes it correct. Because our question is asking us to find out which of the statements is incorrect. Now, why is statement C incorrect? Look at it. It is used to fill gas balloons because instead of hydrogen, because it is lighter and non-inflammable. Well, helium is non-inflammable, but it's not lighter. The atomic number of hydrogen is 1, while the atomic number of helium is 2. That means hydrogen has 1 U, which is 1 atomic mass unit, while a helium atom will have 4 atomic mass units. So helium is actually heavier than hydrogen. The reason why it is used in gas balloons is because of its non-inflammability. That's it. So this statement is incorrect because of the phrase because it is lighter, where in fact it is not lighter than hydrogen. So option C is the only statement here about helium which is incorrect. Next question. What is X and Y in the given reactions? So we have 2x2 plus 2H2O gives you 4H plus 4X minus plus O2. And then we have Y2 plus 2H2O gives you HY plus HOY. So we need to find out which of these is the right one. So when it comes to our options, we have chlorine, fluorine, bromine, and iodine. We need to find out which of these halogens is X and Y. So let's try chlorine in water. Cl2 plus H2O. Cl2 plus 2H2O. So we will have one H and one Cl forming an HCl, plus the remaining elements, which is one H, and there is an O, and then there is a Cl, so it forms an HOCl. So therefore, chlorine is Y. And over here, the only option with Y as chlorine is option C. So it becomes the right option. In option A, it said that Y is fluorine, which is incorrect. In option B, it's bromine, which is incorrect. In option D, it's again fluorine, which is incorrect. Now, what about X? X is fluorine, according to the right option. Let's write it down. So 2F2 plus 2H2O. So we have, so over here, oxygen gas is released. And then we have hydrogen always is H plus, and fluorine is always minus, so 4F minus. So therefore, option C is the right option. Let's look at this question. Which of the following fluorides does not exist? Is it A, NF5, B, PF5, C, ASF5, D, SPF5? Well, let's look at our options. In order to have a pentafluoride, you need to have the presence of vacant d orbital in the valence shell. When it comes to antimony, it is present in the 5th period, so therefore it will have 5d vacant orbital. So therefore this one exists. SPF5 exists. So option D is incorrect. For arsenic, it will be 4D, that is present in the valence shell. So again, it exists, so incorrect. For phosphorus, it is 3D, which exists. I know in the electronic configuration it doesn't appear, but since it is in the 3rd shell always has a d orbital, and the 4th and the 5th. Now they are vacant, so that's why these kinds of fluorides exist. However, for nitrogen, the valence shell is the 2nd shell, and the 2nd shell has no d orbital, vacant or otherwise. So therefore, the right option, the only fluoride among these that does not exist, is NF5. There is no formula called NF5. Now, however, we do have NF3 because nitrogen has the oxidation state N3 minus, so 3-fluorine will satisfy it. So option A, NF5, is the fluoride which does not exist. And this is due to the fact that nitrogen has no vacant d orbital in its valence shell, because the valence shell is the 2nd shell, and in the 2nd shell there is no d orbital. It's only 2s and 2p. When it comes to 3, 4, and 5, we'll have 3s, 3p, and then 3d, then 4s, 4p, 4d, and 4f, 5s, 5p, 5d, and 5f, like that. So let's move on to the final question. Which of the following are peroxoacids of sulfur? Is it A, Carros acid and peroxydisulfuric acid? Is it B, Carros acid and disulfuric acid? Is it C, disulfuric acid and peroxydisulfuric acid? Or is it D, dithionic acid and disulfuric acid? So in order to find out, let's look at the structures of each of these acids. So this is H2SO5, it's called Carros acid. And when it comes to a peroxy linkage, let's write it down here. So a peroxy linkage is, so if this is the element X, then there must be a linkage like this for the acid to have a peroxy linkage, and that's when it's called a peroxoacid. So in Carros acid, you see that there are two double bonded oxygen atoms. There's one OH on the left side, but on the right side we have OOH. So this is the peroxy linkage present in H2SO5. So that gives you the idea that options C and D are incorrect. Let's look at our next acid. This is H2O6. It's called dithionic acid. Does it have any peroxide linkage? No. All of the oxygens are directly bonded to sulfur. There is no oxygen which is bound to another oxygen atom, forming a peroxy linkage. H2S2O6 has no peroxy linkage. What about H2S2O7? Because we know that H2S2O6 is incorrect, and the option that has it is already incorrect. Now, H2S2O7. This is known as disulfuric acid. Now, again, as you can see, all of these oxygen atoms are directly bound to sulfur. Even the one that's in the middle, even that is directly bound to both the sulfurs. So therefore, there is no peroxy linkage here. So since H2S2O7 does not have peroxy linkage, we can also eliminate option B because it has H2S2O7. So therefore, the right answer is option A, H2SO5, Carros acid, and H2S2O8, which is peroxydisulfuric acid. And in order to prove it, here's the structure. Peroxydisulfuric acid, see the bond right here. This is a peroxy linkage. There is a bond between two of the oxygens. Well, in H2S2O6 and H2S2O7, there is no bond between the oxygen atoms. Either the bond is between S and O or O and H. Between O and O, there is no peroxy linkage. So therefore, option A, which contains H2S2O5 and H2S2O8, is the right option. And that concludes this episode of NEET preparation. Now, we have a lot of episodes on NEET preparation. If you want to check those out, then please don't forget to click the link in the description down below for the playlist, and you can enjoy more of our videos. For more useful and interesting content, don't forget to subscribe to our channel, Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.